Hi, welcome back. As we already stated in the previous video, that nearly every measurement is a number plus a unit. So the choice of a unit depends on the quantity being measured. So how do we measure any physical quantity? Basically, we measure any physical quantity by use of a number, and we follow it by the with the units. So let's go through this. So here, measurement of mass, for example. Sorry. So let's go through here. So measurement of physical quantities. So if you are having this as your physical quantities, you will not measure, for example, these using we have to use a standard reference of measurement. So measurement has to be done with a standard. So what we are having here, this is the standard measurement of the unit. So these are the standard ones. So we make comparison with the quantities that we have. So if you have 2 kilograms here, then you are, so we have the units are the kilograms, and the magnitude is how many we have here. So if we are looking at this is a physical quantity and it's 2 mirrors. We have 5 kilograms as being the magnitude and this being the unit. So the magnitude must be multiplied by the unit in order for us to get the numerical value. So quantity may be in different units. For distance, maybe 100 kilometers will be approximately 62 miles. So we are looking at height. So if you are tall, we will measure with different units, and if you are short, we will measure with different units as shown here. With this guy, we are using mirrors, and if he is shorter, we might use feet, depending. So the units depend on what we need. So quantity has name, symbol, and magnitude. So for example, this is the name. It may be length. Its length, a length can be having the symbol L, and the magnitude can be like 3 meters. So unit So we will proceed with the needs of this unit, which is the SI. So the unified system of units are what we are calling the SI. So let's look at how the SI units were derived and reached at. We want to see how they were derived and reached at, and I think it is not as an easy task as it may look. So So we are saying here that many centuries ago, people sometimes marked off distances in numbers of feet. Maybe people measured distances in numbers of feet. But at that time, everyone had a different size of feet. So there was no specific unit that was there to be used by the people. So the choice of unit depends on the quantity being measured. So we are saying here that people sometimes marked off distances in the number of foot length it took to cover the distance. But this system was unsatisfactory. Think about it yourself. Think about measuring with feet until you cover a long distance. It is really hectic. So the number of feet lengths used to express a distance also varied in size. So the number varied in size. Some people had bigger feet than others. So once there was agreement on the standard for foot length, confusion as the actual length was eliminated. So if people come and sit together and discuss and have an agreed standard, they solve the problem that was being brought about by confusion of differences in feet and so forth. So it no longer mattered who made the measurement as long as the standard measuring unit was correctly applied. So in the science world, we use SI measurements. In the science world, we use SI measurement. We use SI measurements. So these SI measurements are internationally recognized measurements. These are internationally recognized units. Because they are internationally recognized, it's no big deal using them. Because they are internationally recognized, it is easy for people to use them. So scientists all over the world have an agreed measurement system, which we are calling le système international des units. That is because this was derived in French. At first, it was called in French, I am not very good in French, le système international. Le système international des units, which is abbreviated as SI, abbreviated as SI. So this is where the SI comes from. This system was adopted in 1960 by General Conference on Weights and Measurement. So SI now has 7 base units. It has seven base units. It has 7 base units, which are commonly used by chemists, which are commonly used by people. So the most other units are derived units. So other units are regarded to be derived units. Other units are derived units. So what we mean here by derived, we mean that these ones will be derived from the 7 basic units. So some non-SI units are still commonly used. Some non-SI units are still commonly used. Some non-SI units are still commonly used by chemists, and also we will be using them as we continue to study. So SI units are defined in terms of standards of measurement. So the standards are objects or natural phenomena that are of constant value, so easy to be preserved and reproduced and practical in size. So international organizations monitor the defining process. International organizations monitor the defining process. So you can't just come up with your own units and claim they are SI units. Why? Because one, these SI units are constant values. They are constant values. Easy to preserve, and reproduce, and practical in size. And practical in size. So you cannot, for example, use a house as a unit of measurement. How will you be lifting the house to try and compare materials with it? So in the United States, the National Institute of Standards and Technology plays the main role in maintaining standards and setting system convention. If we take, for example, a number like 7,500. 7,500. This is how it is written. This is how it is written. And not 7,500. Why? Because this comma here is used in other countries to represent a decimal point. The comma is used in other countries to represent a decimal point. So for it to be international, or we should avoid using the comma and rather write 7,500 without the comma. Without the comma. We will go ahead and look at prefixes added to SI base units and how they indicate quantity. So we will be looking how they indicate larger or smaller quantities, and this is what we will be looking at next, that prefixes added to SI base units indicate larger or smaller quantities. So the 7 SI base units and their standard abbreviation symbols are listed in a figure here. Let me show you where it is. So to sum up with our discussion, we will go ahead and look here. Scientists measure, most scientists' data comes from measurements. So standard is needed here. Standard is needed. Maybe you might ask why we need the standard. We need the standard for accuracy and precision. Let me go back a little bit. So here we say, so a standard is needed for all the scientists so that we are able to communicate with one another and without any problem. A standard keeps data accurate, precise, reproducible, and unchanging. These are some of the advantages of using standard measurements. So scientific measurements, we have the metric system and the SI and CGS systems. So the metric system introduced in 1791 during the French Revolution. The metric system is based on the powers of 10. So that power 10 means 1, and power 1 means 10, and so forth. And they continue like that. Metric systems of length mirror, mass grams, volume lira, time seconds, and temperature Celsius. So the 7 SI fundamentals, or the base units, SI units, are length, mass, time, temperature, electric current, luminosity, and amount of substance. Length mirror, mass kilometer, time seconds, temperature Kelvin, electric current is measured in amps, lamp in candela, and amount of substance is measured in moles. All these are essential for a scientist. So derived units are created from fundamental units such as volume. So we will be looking for these details in the next session. For now, we will stop here.